with confidence interval difference between two mean. So actually, we already discussed about confidence interval for a single population mean on our last class. So that one, you have three cases to consider. So either your sigma square is known, okay, and then we have the case for large sample size, okay, and greater than 30. But your case is sigma square is unknown. So when you have your sigma square is unknown, so that means you need to estimate your sigma square using your variance sample. And then the next one, we have case sigma square is unknown, but you have a small sample. So that one, we will proceed with using T distribution. So for case T distribution, so again, T is a ratio, okay, ratio of standard normal and also chi-square distribution. So we already defined, let's say we have W, okay, W is your standard normal. For example, you have X bar minus mu over sigma over square of N. And then you have your V. So V is your chi-square distribution, which is you have N minus 1 S square over sigma square. So that one is distributed as degree of freedom, chi-square, and then you have N minus 1 as your degree of freedom. So we take the ratio. So it becomes T distribution. So actually when we conduct T distribution, so because we have small sample size, normally we will assume that your data is coming from normal distribution. Okay, but later on, if you proceed your studies, let's say doing research, then you need to justify ataupun validate whether your data is normally distributed or not. Okay, sebab again, what you learn so far, I think from your first year sampailah kita ada final year lah ya untuk subjek statistik. Okay, mostly is parametric punya statistik. Okay, we have two types actually, parametric and also non-parametric. So non-parametric tu normally we conduct without normality assumption. Okay, kalau tak ada normality assumption, then we will conduct our test using non-parametric approach. Okay, so this one again, you have difference between two population mean. So the first case is your sigma square x and also sigma square y are known. Known tu maksudnya it already stated in the question. Let's say you have your x is normally distributed as mu sigma square is equals to 5. Okay, katakan y pula mu y and then sigma square is equals to, let's say, equals to 9. So that is your case variance known. Okay, so when we start to derive, so again, you have your random sample x1, x2, xn, and also you have y1, y2, ym. Okay, two different sample size. So, but again, they are independent. Okay, independent random sample. So, keyword here, your random variable must be independent random sample. You take size n and also size m. Okay, taken from two independent normal distribution. So, write down what is your normal distribution. Let's say lah, we have your mu x. Okay, let's say x is normally distributed, you have your mean. So this one is your variance. So same thing. Y is normally distributed, mu y, sigma square y. Okay. And then we have another random variable, which is your x bar and y bar. Okay, x bar, y bar is your sample mean. Okay. And they are mutually stochastically independent. Okay, independent random variable. And then suppose that your sigma square x and sigma square y are known. Okay. So this one, yeah. And then we can read this one lah. Kita ada x bar. Okay, ini saya tulis ni adalah x dan juga y. Kalau x bar, everything must be divided by your sample size, your variance. Okay. So ini, let's say if your notes here, ini betul kan? Kalau let's say saya ada salah, kan? So this one, x bar is normally distributed mu I, your variance sigma square x over n. Okay. Y bar, your mean mu y, sigma square y over m. Okay, your sample size. Then we take a difference, x bar minus y bar. Okay, so x bar minus y bar, so mean mu x minus mu y, variance kita tambahlah ya. So itu dia punya condition lah ataupun dia punya formula dia. Variance memang kita tambah sebab asalnya macam inilah kita ada you will have variance x bar minus y bar. So you will have variance x bar and then plus minus, okay. So that's why kita dapat variance x bar plus variance y bar. So that's why the formula is sigma square x plus sigma square y over n. Okay. So denote a random variable. Okay, let's say dia punya standard normal dia, you will have your x bar minus y bar minus the difference between two population mean divided by square root of variance. Okay. The same thing, you want to construct a 1 minus alpha percent confident interval. So kita nak construct this one. Okay. So since this one is normally distributed, okay, normally distributed, you have your standard normal curve. Okay. So again, here is your minus z alpha over 2. So this one is z alpha over 2. So this one is your 1 minus alpha. So the probability, your z, is between minus z alpha over 2 and z alpha over 2 is 1 minus alpha. Okay. So the rest two, the same thing. Okay. Kita bawa naik ke sebelah kiri, sebelah kanan. So, but you need to show in your derivation. Jangan terus bagi you punya solution yang last kali ni. Tunjukkan macam mana kita derive. So let's say you have your s bar minus y bar minus mu x minus mu y. So this one less than z alpha over 2. Okay, your variance. Okay, equals to 1 minus alpha. Okay. So the same thing, kita nak rearrange dia punya yang kat tengah tu kita nak estimate adalah difference between two population mean. Okay, so you bring on your left side lah. So kita ada this way, so probability. So that's mean you will bring okay. So kata inilah dulu jadi. Let's check the probability. Sigma square y or m. So this one kita ada mu x, mu y. Okay, the same thing, ini pun sama, kita bawa ke sebelah sini, negative x bar, y bar, plus z alpha over 2, square root sigma square x over n, plus sigma square y over n, equals to 1 minus alpha, dia punya probability dia. Okay. So, cuma kat sini kita ambil lah, kita solvekan inequality dia step by step. So, katakan let's say the first step, you take negative mu x minus mu y, sorry, less than negative x bar y bar plus z alpha over 2 square root sigma square x over n plus sigma square y over n. Okay, so katakan ini 1a. Okay, so kita selesaikan dia punya ni. So that's mean you have negative mu x minus mu y less than negative x bar minus y bar plus z alpha over 2 square root sigma square x plus sigma square y over n. So kita nak cancel out your negative value. So bila kita cancel out dia punya negative value, so kau punya inequality tu bertukar. So daripada first equation 1a tu, okay, you will get mu x minus mu y. So lebih besar pada x bar. X. N plus sigma square y. Okay, kau betul ke lah ya? Let's see saya dulu. Okay, so ini kamu cancel out kan dia punya negatif dia. Kan? Negatif mu x minus mu y less than z alpha over 2. Okay. So bring to the left and also the right lah. So let's say kamu derivkan equation 1a and then equation 1b. And then at last tu kamu rearrangekan balik dia punya inequality dia. Then baru kamu dapatkan dia punya the last equation that we have here. Cuba derivkan dulu. Kalau saya ada salah plus minus ke situ. Ataupun kalau kamu nak mudah, kita susun sebelah sini je lah. Sebab kamu nak ada mu x minus mu y, so bawa ke sebelah kiri, sebelah kanan je lah negatif tu. Saya buat cara yang panjang pula. Sekejap ya, saya padam balik. Okay. Okay, so just bring this one on the left side and also the right hand side. Okay, fikir cara yang panjang pula. Okay, sorry ya. Okay, so this one, so let's say this one kamu bawa sebelah sini je lah. Okay, so here we just have here minus z alpha over 2 square root sigma square x over n plus sigma square y over m. Okay, so again here, so dia akan jadi macam ni lah, mu x is okay. So ini katakan 1a. Okay, so ini kiranya saya bawa ke sebelah macam tu lah ya, sebelah kiri. So jadi x bar minus y bar, ini bawa ke sini lah, x bar minus y bar minus z alpha over 2 square root sigma square x over n plus sigma square y over m. Okay, so the same thing here. So yang kedua tu katakan equation 1b. So you will have x bar minus y bar. Okay, so this one is greater than. So ini bawa ke sini. Okay, so this one you will have plus z alpha over 2 sigma square x over n plus sigma square y over n. Okay, so this one should be greater than mu x minus. So last tu you, okay, last kita susunkan balik kita punya value dia. Okay, so that's mean this one you will have rearrange the inequality. Okay, so rearrange back 1a and also 1b. So you will have x bar minus y bar minus z alpha over 2 square root sigma square x over n plus sigma square y over m less than mu x minus mu y. So ambil baliklah ini. X bar minus y bar plus z alpha over 2 square root sigma square x over n plus sigma square y over m. So itu kita punya derivation of your confidence interval. Okay. So yang pentingnya kat sini, so kita ada case dia, case sigma square x and sigma square y are known. So that means you don't have to estimate your variance. Okay, because that one is already given. So what you have your random variable is just x bar and also y bar. So both x bar and y bar are mutually stochastically independent process. So x bar is normally distributed mu x sigma square x over n. Y bar kita ada mu y sigma square y over m. Okay, so this is your standardized form. Okay, so kita nak construct 1 minus alpha confidence interval. So probability is equals to 1 minus alpha between minus z alpha over 2 less than z alpha over 2. Okay, so set up kan. So again, kamu do some modification. Which one yang lebih mudah? Buatlah itu. And then back, kamu rearrange back your inequality and then baru kita dapatkan this one. Okay, so this is your last formula that we will have here. So kita ada mu x minus mu y. Okay, so dalam arti kata lain tu, kalau say katakan kamu nak dapatkan mu y minus mu x pun is the same thing lah. Cuma kat sini mungkin kita ada y bar minus x bar. Mana-mana satu yang kita anggapkan sebagai first population ataupun the second population. So either one. Okay, so that is how you construct your confidence interval. For case variance unknown. Okay, ini direct je. Okay. So again, for case yang kedua, katakan kita ada variance population are unknown. But again, for large sample size. Okay. For large sample size, we will have the random variable that we will have is your x bar, y bar, and also s. Kita ada sample variance. Okay. So the same thing, kita akan start x1, x2, sn, and y1, y2, ym adalah independent random sample. Okay, two independent normal distribution. Okay, which is coming from mu dengan dia punya variance je. Cuma kat sini kita ada x bar and y bar is denoted as sample mean. And then suppose your sigma square x and sigma square y are unknown. Okay, so kat sini mungkin kita boleh tambah. Suppose sigma square x and sigma square y are unknown. Okay, given that, your s square x is just 1 over n minus 1 summation xi minus x bar square, or s square y is just 1 over m minus 1 summation yi minus y bar square. Okay? And again, both these random variables are also independent. Okay? So that one, So again, you can construct your confidence interval, okay, by writing kita punya standard normal kat sini, dia akan jadi instead of kita ada x bar minus y bar minus mu x minus mu y, okay, divide by square root s square x dan juga s square y lah dalam kes ni. Okay, so you will have here, so kita ada standardized form dia z ataupun w, either one, x bar minus y bar minus you punya difference mu x minus mu y square root s square x over your sample size s square y over. Okay, so that one. So itu adalah case for variance unknown with large sample size. So kalau large sample size, still you use normal distribution. You have your z distribution. Okay, nah construct sama juga. Kita dah ada ini. Dapatkan negatif z alpha over 2 less than z alpha over 2 equals to 1 minus alpha. So just replace. Okay, so modify and then the last answer you will have this one lah. Okay, same thing. Derivation dia. Cuma dia ada add-ons je. Yang ambil yang first tadi. Okay, ini. Cuma tukar sigma square x, sigma square y are unknown. Okay. Given that your s square x and also s square y are also independent. So s square x adalah this one, your variance for sample. S square y, variance sample for y. So both are independent random variable. Okay. Then you have a random variable z is defined as this one, x bar minus y bar minus mu x minus mu y divided by square variance for sample divided by sample size. Okay. Then you want to derive a 1 minus alpha 100% confidence interval. So start lah. Probability this one minus z alpha over 2 less than z alpha over 2 sama dengan 1 minus alpha. And then show how you get the formula. Okay. So itu case for large sample variance. Okay. So ini saya tak tunjuk lah. Kamu boleh cuba sendiri this one. The same approach je. Okay. Derivekan balik dia punya confidence interval. Okay. So next kita nak tengok case yang ketiga. Okay. Case ketiga. Small sample size, but again you will have sigma square x, sigma square y are unknown. Okay, sebab kalau case yang ketiga tu dia melibatkan t distribution and also you have a random variable standard normal dan juga chi-square distribution. Okay, two random variable. Okay. So again, the same thing. Kita ada independent random sample. You will have x1, x2, xn. y1, y2, ym is also independent random sample from two independent normal distribution. Okay, so okay. Cuma kat sini kita ada x bar, y bar, sample mean. Again, s square x, s square y, your sample variance. And these random variable are independent. Okay, you have a random sample, and then you have 4 random variable and ataupun 4 statistik dia. So these are independent. Okay. So kalau nak tambah s square x tu apa? So gantikanlah s square x is this one, s square y is this one. Okay. And again, when you want to define your s bar is normally distributed. You have your mean mu, variance sigma square over n. Y bar, mean mu y, sigma square over n. Okay. So again, untuk case yang ketiga ni, sama jugalah case kedua pun ada, cuma dia jarang digunakan. Kita ada assumption where you have your both population variance are equal. Okay, katakanlah mula-mula kat sini seletak dulu sigma square x, sigma square y. Yeah. So assume that both population variance are equal. Okay, both population variance equal. So that's mean here you have sigma square x equals to sigma square y is equals to common term, which is sigma square. Okay. So kat sini dia dah replace So kita ada x bar minus y bar, mu x minus mu y. So katakan kat sini kita dah replace sigma square x tu sama dengan sigma square. Again sigma square y pun sigma square. So sigma square over n plus sigma square over m. Okay. So standard random variable. Kita dah ada s bar minus y bar minus the difference divided by square root for your variance. Okay. So dia ada common term. So kalau kamu recall back your first year punya statistik, when you have your common term, we have this one as pool estimator for variance. Okay, pool estimator for variance biasanya kita pakai SP square ni. Okay, so which is standard for standard form lah. Okay, untuk pool estimator. Okay, SP square. So again, so this is your random variable. Okay, taburan Z. Note that you have chi-square distribution. So since you have two random variable, x and also y, so we also have two independent chi-square distribution. So kita ada n minus 1 s square x over sigma square, which is chi-square n minus 1. So this one, m minus 1 s square y over sigma square is just chi-square m minus 1. Okay. So two independent chi-square distribution. Okay, this one is normally, is distributed as chi-square n plus m minus 2. Okay, so kalau kita add two independent chi-square, it will give you n minus 1 s square x over sigma square plus m minus 1 s square y over sigma square is distributed as chi-square distribution, degree of freedom n plus m minus 2. If you have one sample t, okay, you just have n minus 1. Tetapi kalau kita ada two sample ataupun two population, you will have n plus m minus 2. Okay, so assume this one are independent. So kita nak masukkan dalam taburan T, dalam dia punya ratio tadi tu. Kita dah tahu yang asal itu saya tunjukkan. So katakan W for normal, kita ada square root V for chi-square divided by degree of freedom. Okay, kamu dah faham ini konsep ni for one sample. So for two sample pun it's the same thing lah. Cuma kat sini kita ada standard normal dia. X bar minus Y bar minus the difference. Okay, divided by square root for your variance. So this one, kita dah ada tadi. Okay, n minus 1 s square. Okay, plus m minus 1 s square y over sigma square. Divided by degree of freedom dia adalah n plus m minus 2. Okay, and then simplify kan lagi. Okay, sigma square. Fakturkan dalam 1 over n plus 1 over m. Okay, ni. So, okay, this one. So, kita hilangkan dia punya, cancel out your sigma square here. Okay, so keluarkan sigma square, tinggal sigma lah. Ini pun sigma. So, cancel out, dah tak ada. So yang tinggal ini je, n plus m minus 2. Okay, so rearrange balik, you will have 1 over m plus 1 over m. Okay, rearrange lah numerator, denominator dia. Okay, so then you have here is your t distribution. Okay, t distribution, random variable t. So this is the formula that you will use to construct your confidence interval. Okay, S bar minus Y bar minus the difference square root your variance. Okay, biasanya bila kita pakai pool estimate tu, dalam formula if you have your stats table, so ini adalah formula pool estimate kita. Okay, so the S square Y and then you will have N plus M minus 2. So this is what we call as pool estimator for variance. Okay, pool estimator. So pool estimator we only use when you have the assumption both population variance are equal. Okay, so you have this one. So you when you want to construct your confidence interval, the same thing you take kiranya kita ada probability negative t alpha over 2. So katakan saya letak dulu n plus m minus 2 here less than t alpha over 2 n plus m minus 2 sama dengan minus alpha. Then kita replace lah t kita dengan random variable ni. And then after that you will modify and then get lah this one. Okay. So itu kita pakai confidence interval, kita nak solvekan confidence interval for 1 minus alpha. Okay. So B ni just notation je lah ya. Kita ada T alpha over 2 M plus N minus 2. Okay. So yang ni kalau N minus 1 S square X plus M minus 1 S square Y, you nak replace sebagai SP square pun boleh jugalah. Okay. Nak meringkaskan kita punya dalam kerja tu. Okay. Ataupun derive je lah semua ni. And then you substitute and build up your confidence interval. Okay. Itu dia punya confidence interval for T distribution. Okay, again, dia punya key point here, you have a random sample, 2 independent random sample, you have 4 variable, you have X bar ataupun 4 statistics here, X bar, Y bar, S square X, S square Y, and then keempat-empat ni adalah independent. Okay, and then you have your X bar is normally distributed as Y, Y bar pun sama. Okay, ambil difference dia. Sebab kita nak construct confidence interval, difference between two population mean. Okay. Assumption, assume that both population variance are equal. So you have this one sigma square. Okay. So again, when you have T distribution, you will have your chi-square. So kita ada first random variable dengan second. Okay. So masing-masing adalah n minus 1 s square x over sigma square distributed chi-square n minus 1. So kalau kita add, you will have this one lah. Okay. And then take a ratio. My random variable, take a ratio. W over square root V over R. Okay, R is your degree of freedom. Okay, simplify, you get this one. And then you construct your confidence interval. You by writing probability between minus T alpha over 2 less than T alpha over 2, the probability given is 1 minus alpha. And then expand lah. Expand and then you conclude what is your confidence interval. Okay, so ini actually kamu boleh refer juga pada nota, cuma dalam nota saya tu, okay, dalam nota saya tu ringkas ya. Kalau ringkas maksudnya saya tak tunjukkan dia punya derivation. So again in your solution show macam mana dia punya derivation tu. Okay, yang nota yang awal kita ada, kalau if you refer to your notes you get that 0.1, 2, 3, 4 up to 5, 6, 7 tu dah ada Cuma kat situ derivation dia je kamu tambahkan kat situ macam mana kita dapat the last formula. Okay, itu confidence interval for T distribution. So the same thing juga confidence interval yang lain tu. Okay, yang saya tak tunjukkan dalam nota tu mungkin yang itulah kita ada large sample but your case variance are unknown. Okay, so again you will have X bar, Y bar and then kita ada S square X, S square Y. Again empat-empat statistik ni adalah independent. And then baru kamu derive kamu punya confidence interval. So itu untuk case large sample, still you use Z. Okay. But case for small sample, then you use T distribution. Okay. Boleh. So itu just sebab biasanya kalau let's say kelas fizikal, biasanya saya suruh student present bahagian ni. Okay. And then write down lah dia punya macam mana dia punya derivation. Okay, biasanya. Okay. So that one, ikut taburan T distribution. Okay, let's us refer to your exercise, ya, example. Okay, example ni adalah untuk taburan T. Okay, taburan T distribution. So already given here, you have two independent random sample. Okay, unknown variance, but assume the same. So maksudnya kat sini kita ada sigma 1 square sama dengan sigma 2 square is equals to sigma square. So you will have your pool estimate. Okay, pool estimate. So ini sama balik dengan what you already learn lah, ya. Kita nak dapatkan find a 95% confidence interval. Okay, so let's say the first part you already derive. Okay, using that formula that you already derive, solve this equation, find a 95% confidence interval. So the same concept here. So first tu kita akan pakai T distribution. So you will have here is 1 minus alpha 0.95, alpha 0.05. So again alpha over 2 is 0.025. Okay. So we already given here is the assumption case variance population are equal. Unknown variance. So that's mean you need to estimate. Okay, which is S square 1, S square 2 ataupun S square X, S square Y. Kita letak X, Y lah, ya. X. Okay, this one is Y. Okay. So that's mean kita ada assumption sigma square X is equals to sigma square Y, which is sigma square, which is your pool estimate. Okay. So you need to construct 95% confident interval. Okay. First, kita dah ada, this is the formula. Okay, but to make it much more easier in your calculation, so let's say kita pakai pool estimate. Okay, kita denote that one here, this one term as pool estimate lah, SP square. Okay, so that means you will have n minus 1. Okay, so size is size 10. Okay, so 10 minus 1, S square X, S square Y. Okay, so plus again 10 minus 1, S square Y kita ada 7.88. So 10 plus 10 minus 2. So that is your pool estimate. Okay. So cuba dapatkan apa dia kamu punya nilai SP square here. Okay, cuba kira. Bagi jawapan dalam 2, 3 ataupun 4 decimal point pun okey.
Betul 8.26.
8.26. Okay, thank you. Okay. So this one kita dapatkan dulu dia punya taburan T. If you already have your stats table, so T alpha O2 0.025. So kita ada N plus M minus 2. Okay, so 10 plus 10 minus 2. So degree of freedom 18. Okay, check dengan saya punya ni. So taburan T nak baca table ingat kan 2.101. Okay, so find your alpha, find your degree of freedom. Okay, so write down dulu apa dia punya formula dia. So you have X bar minus Y bar plus minus T 0.025, degree of freedom is 18. Okay, so katakan ini saya pakai SP square 1 over N, 1 over N. So this is the formula. Okay, and then the rest tu kamu masukkan je lah. So you have 4.8 minus 5.6 plus minus 2.101 8.26 10 plus 1 over 10 lah ya. So ini pun sama lah. Okay, depends lah ya. Berapa. Kalau let's say memang boleh dapatkan 3 or 4 decimal point. So kamu boleh masukkan apa dia punya lower limit, apa dia punya upper limit. Okay. Kecuali lah tu memang 1 decimal point memang negatif, katakanlah 3.500. So letak je lah 3.5. Okay. Boleh dapat? Memang lower limit, upper limit. Okay, last answer. Boleh dapat? Last answer. Apa dia punya lower limit, apa dia punya upper limit? Tulis dalam chat pun boleh. Lower limit dia apa, upper limit dia apa. Okay, lower negative 3.5, 1.9. Okay. Okay, thank you. Okay. Negative 3. Okay. Again, dalam saya punya ni, okay, tapi okay, biasanya kita punya confidence interval, kalau kamu recall back first year, cuma dalam nota ni tak ada, kita tak mention lah Untuk taburan T, kita ada juga case kita which is variance population equal and also unequal. So equal ni kita pakai pool estimate ni yang kita buat ni. Okay. But again, dia ada juga unequal population variance. Okay. Unequal population variance, dia konsep dia again lah case variance are unknown. So again you start x bar, y bar and then you have s square x, s square y. Okay. Cuma untuk taburan T here, yang biasanya adalah degree of freedom. Okay, degree of freedom dia ada formula dia how you want to compute your degree of freedom. Okay, dia ada calculation lah V dia. That is the formula. Kalau tak maksud saya dalam stats table list of formula pun ada. So itu for case unequal population variance. Okay, itu yang kamu dah belajar dalam first year punya statistik. Kalau difference between two population mean, actually dia ada 5 formula that you have to know lah. Okay, so first case, bila case kita variance unknown. Okay, variance unknown, tak kisah, large sample, small sample. As long as your variance population unknown, you still use normal distribution. Okay, ini yang first case tadi tu. Okay, this one So second, when you have again case variance are unknown, you need to check what is your sample size. Large sample, small sample. Large sample, you proceed with Z, okay, Z distribution. But for small sample, you need to have a T distribution, okay, and let's say an X and Y less than 30. So itu kita proceed dengan menggunakan T distribution. Okay, kalau case variance unknown, large sample large sample pun dia ada juga assumption dia, equal variance or unequal variance. Tapi cuma yang ni, yang dalam nota tu cuma tunjukkan unequal population variance So that's why kita splitkan dia punya confidence interval. Katakan dia equal population variance, so sama juga lah kamu ada pool estimate. Okay, cara nak construct dia sama. Probability between minus Z alpha O2 less than Z alpha O2. Cuma Z kamu tu instead of kita ada S square X here, S square Y ni, kita ada pool estimate lah. Okay, which is the same thing here. Yang dalam taburan T ni. Kita ada ni. Okay, itu je dia punya beza. Cuma last sample, kita still use Z distribution. Okay, untuk last yang taburan T ni, when you have small sample, again, check your assumption, equal population variance, you have pool estimate. Okay, and the degree of freedom is just N plus M minus 2. But if you have unequal population variance, it's quite different dia punya degree of freedom. Bezanya dekat degree of freedom lah. Okay, cuma kat sini satu lagi, kita ada, sini je lah ya. Okay, you will have here is just T X bar minus Y bar minus the difference mu X mu Y. Okay, beza dia ini je square root S square X over N katakanlah S square Y. Okay, cuma dia ada katakanlah di alpha V ni, degree of freedom ni yang kita compute dengan menggunakan certain formula. Okay, so itu adalah confidence interval. Tapi yang biasanya ditanya yang ada dalam nota sajalah ya. Okay, so biasanya kita ada apa? Case variance unknown, small sample, large sample, and then you have the case when you have the equal population variance. Okay, for difference between, this is for difference between two population mean. Tapi kalau a single population mean, kita ada 3 formula je lah ya. Tak ada assumption lah equal population variance ataupun tidak. So kalau that one is just case variance unknown, Z. Okay, case variance are unknown, but last sample still Z distribution, and then the last one case variance are unknown, small sample, then you use T distribution. Okay.